Would you like to learn the fundamentals of cloud computing? Are you an aspiring cloud architect or an aspiring cloud engineer? Would you like to know the difference of a virtual machine and a container? Well, if so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing and networking careers. I've been working in this industry for over 25 years, and I've been coaching or mentoring others for 2 decades now, and I've loved that very last minute of it. Today we're going to talk about some cloud architect fundamentals or cloud engineer fundamentals. See, when you're moving to the cloud or you're going to work on the cloud, you have to understand the cloud, which is essentially a virtualized network and a virtualized data center that's hosted somewhere else. But when you're dealing with taking your servers and your compute systems to the cloud, you're going to have to find similar services or something that's going to work well. Now, in most cases, when organizations take their equipment to the cloud, they basically do something called a lift and shift, which is basically taking the virtual machines and containers in their data center and relocating them to the cloud. Now, that's what happens most of the time. Look, there's really cool serverless things that can be done, and in certain environments, serverless makes sense as well. But most migrations are lift and shift. So you've got to know what you're moving to bring it to the new location. And even if you were going to go serverless, you'd still have to have some knowledge of the capacity of your virtual machines and servers from the data center to move it to the cloud. So today we're going to talk about how does cloud computing get performed? The same way as it does the data center. And all cloud computing is going to use one of two technologies, virtualization or containers. So we're going to talk about both of these things today. So you not only know how it works in the network and the data center, and how the cloud actually works, but you'll be able to size and properly provision your systems for your customers in the cloud. Let's talk about virtualization first. When I first went into this industry, many, many years ago, more than 25, but we'll call it 25 so I don't feel old. Basically, we'd buy a server. Here was the process. We'd call the server manufacturer, and they'd build it for us. So we'd call a company like Dell, we'd tell them our requirements, they put the number of CPUs in, the amount of memory we needed, the types of hard drives we needed. 6 weeks later, they'd ship the thing to us. It would get to our doorstep. We were all excited. We'd take it out of the box. We'd then unwrap it. We'd then put it into a rack, screw it into the rack, cable it up. Then to use the server, here's what we did. We installed an operating system, dependencies, and then our applications. And guess what? That server that just took us 8 weeks, this entire process, from start to finish, is now sitting on the rack serving one application. And you know what? When we need more servers, we just get more. We need additional ones. We build, and then we end up with data centers that are like 30,000 square feet that are using megawatts of power, and they're just to power a certain number of servers. Now, good news happened. Computers got really powerful. And instead of CPUs having 1 or 2 cores, now you've got 64 core CPUs, and you can put a bunch of them into a server. Now you can put terabytes of RAM into these servers. You can put RAID arrays into these servers that'll give you 64 terabytes of data with, 500,000 IOPS. And now we've got these big bad servers, and we don't need them for a generic web app. We need them for basically lots of things. So now we can take these big giant servers that we have, and we can basically put something called a hypervisor on them. And with the hypervisor, we can do something called virtualize the server. Now, what is server virtualization? It's when you take a server, you install some software, and you chop that server into multiple logical servers. So now one server, one physical server that takes 6 weeks for us to get, can now become 20 servers or more inside of our data center, all in a single, basically, set of plugs that are being plugged into the wall, all efficient with use to power, and all fast. Because now we've got one of these servers, and as soon as it's here, now I need another virtual machine, I need a new server. I go to the management console of my virtual machine, I create a new virtual machine, and in seconds I have it, just like the cloud. So, what do you think we're using on the cloud? The same thing, server virtualization and containers. So now let's look at the architecture of a virtual machine. We've got our physical server. And the box looks like this, or something that looks like a pizza box that's plugged into the rack. That's our physical hardware. That's where our CPU lies, our memory lies, our hard drives lie. Now, we want to chop this up. So on the server, we install something called a hypervisor. Here's what the hypervisor is. It's a thin layer of software. It's typically like an operating system kernel. So typically, imagine you've got a very thin layer of software, like a kernel, The kernel then will logically chop your system into multiple virtual machines that will manage the CPU resources, the memory resources, the hard drive resources, even graphics card resource. So here's what it looked like, as you can see on this graphic. Physical hardware, hypervisor, and multiple virtual machines. Now, each virtual machine that we're using in this environment has its own operating system and its own applications. So I'm going to say this again. Every virtual machine is like a brand new logical computer. It all needs its own operating system, its application dependencies, and its application. So now we've got one server, we've chopped it up into multiple little servers, and it is great. Now, we've got multiple logical computers. All of this is terrific. Now, if we need extreme security, for example, where if one virtual machine were to die, it could potentially never impact another virtual machine, virtual machines have an advantage. They are more secure. And we'll talk about why they're more secure than containers. If we need extreme isolation, you've got more isolation with virtual machines. If you need more control and something which could protect you from different kinds of failures, which we'll talk about in the container environment, virtual machines are your way to go. So a virtual machine is basically you take the server, you install a hypervisor, and then you install your operating system and applications. Now this is traditional server virtualization. This is called a type 1 hypervisor. Meaning server, hypervisor, no operating system, and then each virtual machine gets their own operating system. Now let's talk about the container piece. Why are containers so cool? So previously, as we described, we've got a server, we've got a hypervisor, and then each virtual machine has its own operating system, which is great. But think about the overhead of having each machine with its own operating system. It's pretty heavy. You know, operating systems take gigabytes just for to run the operating system, and they take gigabytes of memory. What if we could get past this? Well, that's what a container does. A container basically does this. It takes all your servers and puts it all under a single operating system. Now here what happens is you add the container management software and the container software. Now, what is the container? You basically put your application dependencies and the application in these containers. So now, if you want 20 isolated applications, you can make 20 containers. Now, if you were using a virtual machine to have 20 VMs, you'd have 20 copies of the operating system. Not so in the container. The container is going to borrow the underlying libraries from the operating system. So containers are real lightweight, and they are really fast, and they are real efficient. So if you might be able to run, for example, 20 virtual machines on a server, you might be able to run 100 containers or even more. Imagine 100 apps all running on a single server, 200 apps, 300 apps, 400 apps. That's the beauty of containers. So containers are a more modern, more lightweight, faster, and more efficient form of virtualization. Now, we still use virtual machines, and now we use containers, so now you know a lot more about them. In a future video, we're going to talk about Kubernetes and container orchestration, coming very soon. But in this video specifically, we're just talking about what is a container. Now let's talk about what happens. Why is a virtual machine a little bit more secure? Your containers are logically isolated. So in theory, if this line is basically your server's operating system, and you've got a container, and another container, if something happens in container number 3, it should have no impact on container number 2 or container number 1. In theory, it should not. And in generally speaking, they don't. But what happens if the host operating system were to crash? Well, then all those containers sitting in that host operating system potentially could crash as well. So you've got more robustness in virtual machine because every app has their own isolated operating system. So if a virtual machine dies, it can't potentially affect anything else. In the container environment, one container should not affect another container. But should a container go haywire, and I've seen this where it crashes the entire operating system, well then, all your containers crash. Again, that is really rare, and in theory, it should never occur, but I've seen it. You know, what could occur and what does occur is something a little different. Or if the operating system itself were to crash or get hacked, you know, could it possibly affect certain containers? And the answer is it could, but it's not supposed to. But, you know, when you're dealing with tech, when you push systems beyond their use, things do happen. So now you know the difference between a virtual machine and a container. I'm going to summarize it one more time. Virtual machine, take a server, install a hypervisor, create multiple logical computers inside of that computer, each with their own operating system and applications. By comparison, let's take a container. We've got our physical hardware, single operating system, And our containers are logically separated in each other, and all they have is maybe some app dependencies in the container and the app, fast and lightweight. I hope you've enjoyed this video on virtualization versus containers. It's part of our Cloud Architect Fundamentals series, certain things that every cloud architect just needs to know. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Twice per week, we have a free How to Get Your First Cloud Architect Job webinar, where we tell you all the things you need to do and know to get your first cloud architect job. In addition to that, once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I have known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architects.